In this video we have two integrals to evaluate, and it turns out that on this particular one we can use the same U-substitution because these integrals are related somewhat. Now in the first one, because I have x plus 6 here to the 50th power, we can evaluate this thing by expanding it. You don't want to do that though. You multiply this out, you're going to have 51 terms. You go term by term to integrate, but that's not what you want. Now the derivative of x plus 6 is 1. So I can just say, in this case, the integral is going to be x plus 6 to the 51st power over 51 plus c. That's your answer. You can easily check it using the derivative. So 51 comes out of here, cancels the 51, subtract 1 from 51 gives me the 50. The chain rule now, the derivative of x plus 6 is 1. I get the same integrand. That's it for that one. But if you want to make it more clear, you could let u equal to x plus 6 and say derivative of u then, right, it's du. So this would just be du. Derivative of x plus 6 would be 1. Derivative of constant 6 is 0. Derivative of x is 1. So that's going to be 1 times dx. It's just be dx. And then we can transform the integral with this u substitution. And we can write this as the integral of x plus 6. That's your u, taken to the 50th power, and then dx and du are the same, so let's just write du here. Integrate with respect to u. This will give me u to the 51st power over 51, but the u is x plus 6. This will be x plus 6 to the 51 power. That's over 51. That's plus your constant of integration, and that's your solution. Now if you had a constant here of say 5, then the answer would be, you can always factor a constant outside the integral. So you had a coefficient here of 5, same answer except you'd have a 5 multiplying the numerator. Now for the second one, again we let u equal to x plus 6, then du again would equal to 1 over dx. And then we have to transform this integral in terms of u. An x by itself is not allowed, so from here I can solve this thing for x, taking the 6 over, so that'll tell me that x is equal to u minus 6. So now we transform the integral here in terms of the variable u. So this x can be replaced by u minus 6. And of course the x plus 6 is your u, and that's to the 50th power. And the dx can be replaced by du. And then we just do some basic algebra here before we integrate and multiply through. U to the 50th times u will give me u to the 51 power. And then that's minus 6 u to the 50th power. You can write this as two integrals if you want, or you can just do it term by term here. Integrating with respect to u, we simply say, okay, integrate here. We add 1 to the 51 is 52. That's over 52. And it's minus 6 u. Add 1 to the 50, we get 51. That's over 51 plus your constant of integration. And that's your answer in terms of u, but we need it in terms of the original variable, which is the x. So just remember that u is x plus 6. So all I'm going to do is replace the u by x plus 6. I put that on this side over here. So equals, then write x plus 6 to the power 52, and that's over 52, minus 6, and then the u is x plus 6, taken to the 51st power, and that's over 51, plus your constant of integration. And that's really your answer in terms of the original variable. So we could stop here and say, this is your answer right here. Now what you can do here is take the derivative here and check to see if it gives you this. It requires a little bit of algebra. It can be done. I'll let you do that. What I'm going to do, sometimes you want to write this in simpler form. So let's see if we can rewrite this. We can factor out, and see I have an x plus 6 here to the 52nd power, x plus 6 here to the 51st power, so I can factor out x plus 6 to the 51st power. And then what do I have left in here then? Factoring out the x plus 6 to the 50 first power. On the first term, it'll leave me with x plus 6 to the first power. And that's still going to be over 52 here. And then here I'm taking out x plus 6 to the 50 first power, so that's going to leave me with minus 6 over 51. And I still got the constant of integration. And then let's continue. We want to write this as a single expression here, so this will be x plus 6 to the 50 first power. And then on this one, then this will be 50. Let's write this with one denominator, so common denominator will be 52 times 51. So let's cross multiply. So it's 51 times x, that'll be 51x. And then 6 times 51 will give me a plus 306. Cross multiplying here. 51 times x, 51x, and 51 times 6 is 306, and then I'm going to have the minus over here, and then I cross multiply this way. 52 times 6 will give me 312 here, and I get the minus there, plus the constant of integration. And I'm just going to leave the denominator in product form, 52 times 51. 2652, but I'm going to leave it as a product here. And then this is going to equal to then, just a little more simplification here, x plus 6 to 51 power. And then this will give me 51x, and then 306 minus 312 is a minus 6. That's going to be over 52 times 51. And you can multiply that out if you want. I'm going to leave it in that form because I'm going to use this result for an algebra video that I'm going to do for my algebra students. So here's the answer really. They don't tell you to simplify to a certain extent. You can leave it in this format. Or if they tell you to write it as a single expression, here I have that product of these two, and we can leave it in this format. Thanks for watching. We'll see you next time.